July 1st, 2025. NASA's SPHEREx telescope scans deep space, expecting the usual cosmic snowballs, until it finds something impossible. Racing at a staggering 130,000 miles per hour, Comet 3, I/Atlas, is bigger, faster, and stranger than anything ever seen. A rogue traveler from beyond our solar system, defying every rule about what comets should be. Then comes the shock no scientist can explain. A composition overflowing with carbon dioxide, nearly devoid of water, and hinting at origins older than our own planets. 3. I/Atlas is not what we thought, and what it reveals could rewrite the way we understand our place in the galaxy. How did a discovery meant to confirm the familiar unleash a cosmic mystery no telescope has solved? Yet, SPHEREx was built for cosmic history, not for chasing comets. But on July 1st, 2025, its detectors caught a signal that broke the routine. Not a blur, not a blip. An object tearing across the sky at 60 kilometers per second, cutting a hyperbolic path no solar system native could follow. That speed, 130,000 miles per hour, demands attention. The designation came quickly, 3I, only the third time astronomers have given that label, reserved for true interstellar trespassers. Atlas, the ground-based sentinel in Chile, had flagged the object first, but it was SPHEREx that captured the scale. This was no pebble. Preliminary readings suggested a nucleus possibly kilometers wide, its coma already blooming as sunlight struck ancient ice. The raw data told a story of distance and velocity. An object inbound from the southern sky, crossing the constellations at a slant, ignoring the ecliptic, ignoring the rules. Most comets crawl, bound by the sun's leash. 3. I/Atlas arrived as a runaway, its trajectory flung open, its energy unspent. The numbers forced a pause, 60 kilometers per second, eccentricity above 6, inbound from the galactic south. No known planet could have thrown it this hard. No previous visitor had come this fast, this large, this far-off script. That's why the world's telescopes pivoted, not for a pretty tale, but for a chance to catch an interstellar artifact in the act of passing through. SPHEREx, freshly commissioned, found itself at the center of a global scramble. The mission brief had called for mapping cosmic ice and ancient galaxies. Instead, its first headline was a visitor from beyond, one that no model, no survey, no cautious astronomer had expected. Hubble's gaze found 3I/Atlas drifting in a halo of dust, its coma faint and broad, its tail barely more than a whisper against the background stars. In the world of comets, this is the rulebook. Sunlight strikes ancient ice, the surface heats, and water vapor bursts free. That vapor drags dust grains with it, building a glowing cloud that wraps the nucleus, a coma. Pressure from sunlight sweeps the dust into a tail, always pointing away from the sun, stretching for tens of thousands of kilometers. It's the classic picture, a dirty snowball, ice and rock, shedding water as it nears the heat. Hubble's images, taken in July, show exactly what textbooks predict. A soft, diffuse glow, the coma spreading out over tens of thousands of kilometers. The tail, though faint, angles away from the sun, a broad smudge of fine dust. Analysis of the coma's brightness and shape points to water ice sublimation as the driving force, just as it should. The activity matches what astronomers expect from a comet waking up as it approaches the inner solar system. The dust particles are small, their speeds high, suggesting recent exposure to sunlight after a long, cold journey. Hubble's legacy is built on scenes like this, hundreds of comets, each one following the same choreography. Water vapor, dust, sunlight, tail. The pattern holds, the evidence lines up. For 3I/Atlas, every frame confirms the standard. A nucleus hidden inside a cloud of water-driven activity, a faint tail shaped by the sun. The rules seem unbroken, yet beneath that familiar glow, something resists explanation. The surface looks right, the coma behaves, but the details, subtle, persistent, hint at a story that's not quite finished. James Webb's spectrographs slice through the coma of 3I/Atlas on August 6, 2025, exposing a chemical fingerprint that left scientists searching for words. Not water vapor, not carbon monoxide. The signature was carbon dioxide, and not in passing. 8 parts carbon dioxide for every 1 part water. That ratio, 8:1, doesn't just break the trend, it shatters it. Solar system comets rarely reach even half that. Here, carbon dioxide poured out at 129 kilograms per second, while water barely registered, limping along at just 6.6. Webb's near-infrared spectrograph didn't just catch a whiff, it measured a torrent. The mixing ratio stood out as a 6 sigma outlier, a chemical flag planted firmly outside the realm of solar system experience. Astronomers like Martin Cordiner watched as the data streamed in, each spectral line a rebuke to decades of cometary science. The usual suspects, water, carbon monoxide, a smattering of other volatiles, were present, but only as faint echoes. Carbon dioxide dominated every frame, every wavelength, every model. This isn't how comets behave. In the inner solar system, sunlight heats the surface, water vapor bursts free, and the coma blooms with familiar chemistry. But not here. The water vapor was too weak. The carbon monoxide barely more than a trace. Instead, carbon dioxide led every process, every plume, every calculation. The outgassing rates told a story of ancient ice, preserved under conditions unlike anything orbiting our sun. Fine grains of water ice, smaller than a micron, drifted through the coma, but their numbers were dwarfed by the overwhelming tide of carbon dioxide gas. Infrared spectroscopy, the principle behind Webb's detection, breaks light into its constituent colors, revealing molecular identities as sharp peaks and valleys. For 3I/Atlas, the peaks lined up with carbon dioxide again and again, while water's signal faded into the noise. There was no mistaking the result. Not a statistical fluke, not a calibration error. Webb's data forced the question: what kind of world forms with more carbon dioxide than water? What kind of chemistry survives the journey between stars? The shock rippled through the scientific community. If this is what interstellar comets are made of, then our models of planetary system formation need rewriting. The old rulebook, water first, everything else second, no longer applies. 3. I/Atlas is proof. Its chemistry is not just unusual, it's alien. And with every spectrum, the mystery deepens, tracing the path of 3. I/Atlas means leaving behind the sun and planets, and stepping out onto the scale of the galaxy. Its motion is not random, it slices through the solar system at an angle, not aligned with the disk of planets, but tilted, carrying a velocity that sets it apart from almost all local objects. Galactic velocity components, measured to within a few meters per second, give the numbers: -51 in the U direction, -19 in V, +19 in W. These are not the speeds of the sun's neighbors. They're the signature of something older, something from the Milky Way's thick disk. The thick disk is not the familiar spiral. It's a population of ancient stars, born when the galaxy was young and turbulent. Their orbits are more chaotic. Their paths take them far above and below the thin, bright disk where our sun resides. 3. I/Atlas moves with them. Statistical comparisons, chi-squared values, velocity dispersions, show it does not fit the pattern of the thin disk. Instead, its trajectory aligns with the thick disk, matching both the mean speeds and the broad scatter of that ancient population. Monte Carlo simulations, run across 10,000 orbital realizations, push the story deeper. Each simulated pass traces a looping, tilted arc, rising nearly half a kiloparsec above the galactic plane. That's the realm of the thick disk, where vertical excursions are measured in hundreds of parsecs, not tens. Thin disk stars never reach that high. The numbers hold a median Z max of 0.48 kiloparsecs, with tight confidence intervals. It's not a fluke. This is the orbital fingerprint of the old galaxy. Age estimation follows from motion. In the Milky Way, velocity is a clock. Younger stars move gently. Older ones are stirred by billions of years of gravitational encounters. Plug 3. I/Atlas's speed into the age-velocity relation, and the answer is stark. 7 to 14 billion years, depending on the model. The probability that it's younger than a billion? Almost zero. Even with wide error bars, the conclusion stands. This object formed long before the Sun, in an epoch when the Milky Way was still assembling its structure. Metallicity too follows the thick disk script. Stars from this era are poor in heavy elements. The odds that 3I/Atlas came from a metal-rich system are slim. Its chemistry, whatever the details, is likely a record of a time when the galaxy was raw, its building blocks still forming. Each simulation, each statistical test, each velocity vector points to the same story. 3. I/Atlas is not just a traveler between stars. It's a survivor from an era when the rules of planetary formation, and maybe chemistry itself, were different. The question now isn't just what it's made of, but how a relic from the galaxy's youth found its way to our doorstep. On July 1st, 2025, NASA's SPHEREx telescope detected 3I/Atlas traveling at 130,000 miles per hour, faster and larger than any interstellar object previously observed. Hubble's images confirmed a faint, broad tail, but it was the James Webb Space Telescope that delivered the real surprise. 3. I/Atlas is dominated by carbon dioxide, with an 8-to-1 carbon dioxide to water ratio and almost no carbon monoxide present. This finding breaks the established rule that comets are primarily water ice and challenges decades of comet science. Simulations of its orbit suggest 3I/Atlas is 7 to 10 billion years old and likely originated from the Milky Way's thick disk, not our solar system. Yet, its exact birthplace and the process that created its unusual chemistry remain unresolved. These discoveries, drawn from SPHEREx, JWST, and Hubble data, force scientists to reconsider what is possible in the galaxy. For now 3, I/Atlas stands as proof that the universe still holds secrets that defy explanation.